we can use Gauss-Jordan elimination to invert a square matrix of any size. And the basic idea is that the same sequence of row operations that reduces M to the identity matrix will transform the identity matrix to the inverse of M, provided the inverse exists. So this is best demonstrated in an example. So we place the matrix M and the identity matrix in an augmented matrix and perform the elementary row operations on both matrices simultaneously. So first we want zeros below the diagonal, so we start with column 1 and subtract row 1 from row 2, and we subtract 3 by row 1 from row 3. So let's start with row 2. So 1 minus 1 is 0, 3 minus 2 is 1, 2 minus 3 is negative 1, and 0 minus 1 is minus 1, 1 minus 0 is 1, and 0 minus 0 is 0. And now row 3, 3 minus 3 is 0, 2 minus 6 is minus 4, 1 minus 9 is minus 8, and 0 minus 3 is negative 3, 0 minus 0 is 0, and 1 minus 0 is 1. And now we'll zero out the remaining element below the diagonal. So we'll add 4 by row 2 to row 3. So noting that this first element here, plus 4 by 0 is still 0. So we don't modify it. So we have minus 4 plus 4 is 0. Minus 8 minus 4 is minus 12. Minus 3 minus 4 is minus 7. 0 plus 4 is 4. And 1 plus 0 is 1. And now we want 1 on the remaining diagonal entry, so we multiply row 3 by minus 1 on 12. So this element becomes 1, and we get 7 on 12, minus 4 on 12, or minus a third, and minus 1 on 12. And now we'll zero out the elements above the diagonal. So starting with the far right column, we're going to add row 3 to row 2, and subtract 3 by row 3 from row 1. So starting with row 2, we have minus 1 plus 1 is 0, minus 1, which is minus 12 on 12, plus 7 on 12 is minus 5 on 12. And then 1, which is 3/3, minus a third is 2/3. And 0 minus 1/12 is minus 1 on 12. And now for the first row, we have 3 minus 3 is 0, 1, which is 12 on 12, minus 3 by 7, which is 21 on 12, gives minus 9 on 12. And we have 0 minus 3 by minus a third is 1. And 0 minus 3 by negative 12 is 1 on 4. And to zero out the remaining element above the diagonal, we'll subtract 2 by row 2 from row 1. So 2 minus 2 is 0. Minus 9 on 12 plus 10 on 12 gives 1 on 12. And 1, which is 3/3, minus 4/3 gives minus a third. And then we have 1/4, which is 3 on 12, plus 2 on 12 gives 5 on 12. And you can verify that this is actually the inverse of our matrix M by multiplying them together, which should give you the identity matrix. So note that if the reduced row echelon form of our matrix M had a row of zeros, then our matrix would not be invertible.